In the vector array, this has a long history too, and it's from the beginning. It's about 10 years old since we first started. Deep brain mapping. Casey mentioned that making larger probes is more challenging for us because we're working in the semiconductor field, which is really good at small things, but when you start making them larger, it becomes more and more challenging. And so we've had several different approaches to this, and this version, which is the vector, before it had different names, but the vector is just performing stellar. It's really working well. We have a number of different designs, and I'll go into those. This is a chronic vector. So the vector, as we've been talking about it, is a rigid structure that's designed to be used acutely, for short periods of time, and then you remove it. There are a number of people that want a deep brain mapping electrode, but want to permanently implant it and close it up. And so they developed this chronic version, which this is what you're seeing here is the drive and the holder. Mounts on a stereotaxic frame, and you can drive it in, and then it's got instead of a rigid interconnect, it's got a flexible interconnect. So it's the probe, the array is rigid, and it hits the target, and then it's got a flexible interface because it's eventually got to be mounted fixed to the skull. So it accounts for relative brain movement relative to the skull. And then it's hard to see here, but this product can also be incorporated into the optical product line. So you can lay a fiber down here or drug delivery and do the same thing as we talked about earlier for optogenetics.